Page 9, question 1, domain and range. Okay, so taking a look at this graph, we have x-axis labeled length of time in seconds, y-axis distance the ball rolled in feet, okay? Now this graph is called a discrete graph because we're looking at disconnected points. The domain and range of a discrete graph, you literally just find the coordinates of each point, like the little x comma y coordinates, and then once you have all of the coordinates, you take all the x's out of each coordinates, put them in a list in order, that is your domain. You take all the y numbers out of each coordinate, put them in another list in order, that's the range. Okay, that's basically how it works. So for this one, we would do the domain and range that way. So in just a second we will, but let's go ahead and first look and see, is it a function? Function, you can find a graph, if a graph is a function, by doing what we call the vertical line test. You do a little karate chop, vertical, straight up and down line, anywhere and everywhere through that graph. If it ever crosses through more than one point with a vertical line, it fails and it's not a function. So this one only once, but right here you have 2 points going through that vertical line's going through both of those points. So that is a no. Okay? And as we said before, it is discrete. So to find the domain of this, the easiest thing might be to get all of the ordered pairs, all right? Let's come up with a little XY table, and let's get the ordered pairs of every point. So this one is, and by the way, this graph is going by every 2 boxes is 1 going on the x-axis. So we have that, so 1, 2, 3, 4, and so on. On the y-axis, every 4 boxes is 1, so every box is a fourth, or 0.25. Every 2 boxes here is a half, right? So I'll have 1.5, 2.5 in the middle here, 3.5 in the middle, 4.5, 4.5 in the middle, okay? Now that we have that labeled, it makes it a lot easier. This first point is an x value of 1.5 and a y value of 5. No, I'm sorry, y value of 1.5 as well. This next one, we have an x value of 2, a y value of 3. This next one, we have an x value of 3.5, a y value of 0.25. 3.5, 0.25. 3.5 and 1 as well. That's where we have the repeating x's, which is another reason why it's not a function. Here we have 4, 4.25. Here we have 9, 0.5. So it's a little bit of work getting it set up, but literally once you've done that, you're pretty much done. You take all these values, that's the domain, okay? You could put them in order, 1.5, comma, 2, comma, 3.5. Now notice I have 2 of those. I only write it once. 4 and 9. That is our domain in brackets. The range, lowest number 0.5, 1. I'm sorry, 0.25 is the lowest value. I just saw that one. 0.25, 0.5, 1. Then we have 1.5, 3, and 4.25. And that's the range. And that's how you do that. What is the independent quantity? Well, if you remember Dr. Idiot over here on this previous page. Dr. Idiot helps you remember all of the vocabulary that goes with X and Y. Dr. Idiot. And what is a T in idiot? Usually stands for time. Because whether you're dealing with time and money, time and distance, time is almost always an X value, all right? So in this situation, independent quantity, they're looking for X. Well, what is X in this situation? It's the length of time in seconds. Or you could just put time in seconds. That's probably what I should have put. The dependent quantity is Y, which is from Dr. Idiot as well. That is the distance in feet. Let's take a look at number 3. Number 3 says when he's driving at a constant rate, it takes her 4 hours to drive 232 miles from her home in Dallas to her parents' house in Houston. She creates a graph of distance versus time for the trip using this equation. D equals 58t. Let me point out a couple things. This is in the position of Y. This is in the position of X. I also just told you from Dr. Idiot, time tends to be X, right? Here we are seeing that again. All right, you can make a little sketch just so you can have a visual of it. We have time and we have distance. This is Y, right? So, the more hours she's driving, the more distance she's driving, all right? It says constant rate. What that means is our M value is going to be constant, which means this is going to be a line, okay? Now, I'm kind of leading you through all this so you can get to a picture of what the graph's going to look like so you can figure out if it's a function. Well, we're never going to have repeating x's. You can't repeat a moment in time, right? It's not possible. So it's going to pass the vertical line test, and it is a function. Yes. Okay? Is it continuous or discrete? Well, not only are you traveling every hour, but you're traveling every minute, every second, every millisecond in between. And not only are you traveling every mile, but you're traveling every foot, every inch, every tiny fraction of distance in between. So that's continuous. All right? Now, in this situation, what's the domain? Remember, domain is X, range is Y. Domain, since it's continuous, we set it up like this, okay? And range, we set it up like this. And remember, X is talking about time. Well, what are our time values here? It takes her 4 hours. Well, when she first starts, she's at hour 0. When she's done, she's at hour 4. So in hours, that's your domain. All right, distance is miles. Well, when she first starts out, right when she gets in her car, she's at mile 0. And when she finishes, she's at mile 232. All right, what is the independent quantity? We already said it's time. You could say more specifically hours. Dependent, distance. More specifically, it's miles. So those are examples from page 9.